Okay, guys, welcome back. Trig Algebra 3. We are in the first unit, the review unit. Make sure you're hitting up section R6. We're going to be talking about rational expressions. I'm going to take this section, I'm going to break it into at least two parts here. It can be a rather long unit or section. So I want to focus on just where we can see example 1, finding the domain of each of the following. Now, let's back up a bit to the top of the page. It says here, a rational expression is the quotient of two polynomials, meaning it could be written as a fraction. That's all that means. Some examples of rational expressions are 3/5, 2 over x minus 3, and this third one here. Now, in example 1, our goal is going to be to find the domain of each of the following. What that means is when we find the domain of something, it is what x can or cannot be. So the domain of a rational expression is the set of all real numbers for which the expression is defined. Since it's a fraction, and since dividing by 0 is undefined or not defined, any number that makes the denominator 0 is not in the domain. So here's what we're going to do. Again, my goal is to find the domain of each of the following. So here are the steps for finding the domain. We're going to set the denominator equal to 0 to form an equation, and then we're going to solve the equations to find numbers that are not in the domain. I will repeat that. We are finding the numbers for x's that are not in the domain. So let's do what it says in example 1 to find the domain of this. So again, don't worry about the numerator. As the directions say, set the denominator equal to 0. And then here you would just simply solve for x. You would add 3 to both sides. And we would actually want to say x cannot be equal to 3. So therefore, if I was explaining this to somebody and I said, what's the domain of it? You would say it is any x can be any number in the world, except it cannot be 3. Because if it was 3, this is just a side note here to prove it, if x was 3, that would be 2 divided by 0, and we are not allowed to divide by 0. Okay, let's try another more complicated problem to find the domain of this. So again, you can ignore the numerator. We set the denominator equal to 0. We actually want to say, I want to make a correction here on my wording. We actually want to say it cannot be equal to 0, because the denominator is not allowed to be equal to 0. Now, how would I solve this? This is a trinomial that you can get up to 2 answers. Now, you have a couple choices here. You can either use the quadratic formula or you can factor. I know that previously, in the previous section when I was having you guys solve a quadratic, I was having you use the quadratic formula. So I'll keep it consistent with that. So again, just writing down the quadratic formula here. This is what I'm going to be using. Hopefully you guys have that memorized at this point. So the a is 1, b is -4, and c is -5. So if the formula says negative b and the b is already negative, we want to double negative change to a positive. Then plus minus square root of b squared, so -4 squared, minus 4 times a times c, and then divided by 2 times a. And now we want to simplify this and get our two domain values. So remember, when we solve this, your first step is going to be to multiply 3 times. So -4 squared, that's -4 times -4 is 16. Minus 4 times 1 times negative 5 is plus 20. And the bottom, 2 times 1 is 2. After that, we want to reduce the fraction to one number. So we can add 16 plus 20 to get square root of 36. Then we square root the 36. Square root of 36 is 6. Now there's no more radical here, so we can split up and get two separate answers. So the first one, 4 plus 6 divided by 2 is 10 divided by 2 is 5. And the second one, 4 minus 6 divided by 2 is negative 2 divided by 2 is negative 1. So to say what my domain is, I would say x cannot be equal to 5 nor negative 1. Now there is a formal way of saying this for both of these problems. You may see in a text or something, and you might see something in curly brackets, so don't be alarmed. It'll be an x with a bar, so it's saying x is all the real numbers, except that x cannot be 5 or negative 1. I'm not forcing you guys to do that, though. Okay, let's do another one, letter C. Let's find out the domain. So we have a quadratic here, so let's say, all right, not equal to 0. Now, this guy's actually easier. I'm going to save you some time here. I am going to factor here, and this would actually be a lot faster than quadratic formula. The reason I'm factoring is if you look in the denominator, it's a simple GCF of x. So if we pull out an x, we have x plus 9. So that's a really easy way of factoring. So now when we have two factors, what we want to do is set each of these factors equal to 0. So let's call this 1, and let's call this x2, just so we're labeling here. So we're going to say x1 cannot be equal to 0. That's my GCF right here. And we also can say x2 plus 9 cannot be equal to 0. And then we would subtract 9 and go, okay, our second x cannot be equal to negative 9. So to wrap up and summarize this problem, we would say x cannot be equal to 0 or negative 9. Okay, let's take a look at D. Set that denominator not equal to 0. So for this guy, it is a trinomial, but we don't want to use the quadratic formula here because we actually need to GCF first. Notice it's not our normal trinomial that starts with x squared. This guy actually starts with x to the third, and all of the terms have x in them. So therefore I have a GCF of x. So then I'm going to divide everything by x to see what's left over in the parentheses. Remember, when we're dividing by x, we're really subtracting the exponents. So x to the third divided by x is x squared, plus 4x squared divided by x is x, and then minus 5, and the x squareds cancel here. You should not have an x with 5. Okay, so now we can get one of our answers here. We can say, all right, our first guy would say x cannot be 0. But what about our other, where we can actually get two more domain values out of this that the domain cannot be? So you have a choice here. You can either factor this or use the quadratic formula. I personally, again, it doesn't matter what you use. I'm going to factor here just because I'm pretty good at factoring, And this one is, I can tell right away, is easily factorable. I really only use the quadratic formula when either things are not factorable or when a trinomial has a number in front of the x squared. So here, x squared gets split up into x and x. My signs, it shows a -5 here. So that means your signs are plus minus. We call that the C term. Whenever the C term is a minus, it's the signs in parentheses are plus minus. And then I need two numbers that multiply to get 5 and add up to 4. So is it going to be +1 minus 5 or -1 plus 5? We need it to look at the B term here. The B term's a plus. So which of those makes a +4? It would be that. So we need the minus to go with the 1 and the plus to go with the 5. So let's get our other two solutions. We do have to keep going and find out what those x's cannot be. So let's label these 2 and 3 now that they're single x's. Remember, we have the first one here. So we say x2 plus 5 cannot be equal to 0, and x sub 3 minus 1 cannot be equal to 0. So the first one, I would subtract 5. So say x cannot be equal to -5. And the last one, I would add 1 to both sides. So I would say x cannot be equal to 1. So I have my three domain values here. So to wrap this up, I would say x cannot be equal to 0, -5, nor 1. It can be any other number in the world, but if it's one of those three numbers, it's going to make that denominator 0. So we'll stop there, guys, and then what you'll do, you should be good if you scroll down to take a look at assignment R.6A. The short lesson that I just taught here covers 1 through 5, where it says find the domain. So I want you guys to all do that right now. Hit up 1 through 5 and tell me what x cannot be. Okay, guys, take care. Have a great day.